we're going to take a look at the reciprocal function here today. The reciprocal function is really the simplest example of a rational function. We have the equation f of x equals 1 over x. You see that right over here next to the graph. F of x equals 1 over x. We're really looking at taking our most basic function, f of x equals x, the reciprocal of that being, again, 1 over x. So just some key things about the reciprocal function. Number one thing that I want you to notice about this is that f of x is undefined when x equals 0. Undefined when x equals 0. Now, the reason that that is if we take a look at this function, if we found f of 0, we would have 1 over 0. Now, you've learned in other classes and previous topics before that dividing by 0 is no good. We cannot do it. It's one of those rule breakers in math. One way that I remember this is that it is okay to divide 0 by something, but it is not okay to divide by 0. So in this case, since we're dividing by 0, that value, x equals 0, is going to be omitted from the domain. And we see that here with an asymptote, okay? That's where x equals 0. And notice that the function does not hit that point on the graph. A couple other things to notice. The graph is symmetric about the line y equals x and the line y equals negative x. Now, because it's symmetric over the line y equals x, which is this line right here, it's symmetric on that line. If you think back to some of the discussions about inverses that you've seen, when something is reflected on the line y equals x, that means it's an inverse. So if this is a reflection of itself over the line y equals x, then that would mean that the reciprocal function would be an inverse of itself. Again, it's also symmetric about the line y equals negative x. So we have two actual lines of symmetry here for this function. Looking at some of the end behavior and some of the other behaviors of this function, we can take a look at what happens as x approaches 0, as x approaches infinity, and just kind of look at the behavior of this function in those areas. So let's start looking at that next. As x approaches infinity, let's take a look at what happens. This arrow symbol that I have here is a symbol that means approaches, or it gets really close to something. That's really all that means. Okay? So as x approaches infinity, when x gets closer and closer and closer to infinity, if you look at the graph, as the value x gets closer and closer and closer to infinity, further out to the right we go, the function f of x is going to approach 0. It never quite gets to 0, but it's going to get closer and closer and closer to 0. Meaning as we divide 1 by a bigger and bigger and bigger number, 1 divided by that really big number is going to get close to 0, but not quite get to 0. Now, on the other hand, as x approaches negative infinity, so as x goes to the left further and further and further and further, again, you notice that we're approaching 0. Okay? Now, in one case, as x approaches infinity, f of x approaches 0 from above. And in the other case, as x approaches negative infinity, f of x again is approaching 0, but now it's from below, which will make a little bit of a difference as you look at the behavior of that graph. Looking at what happens as x approaches 0. So as x is approaching 0, f of x looks like it's going to get really, really, really close to infinity if we're approaching 0 from the right. So as x approaches 0 from the right, f of x gets really close to infinity. It continues to increase without bound. As x approaches 0 from the left, though, f of x is approaching negative infinity. Okay? You notice here, as x gets really close to 0 from the left-hand side, our graph continues to decrease without bound, so it will be approaching negative infinity. What that means for us then is we end up with two asymptotes. We have an asymptote here at y equals 0. We have an asymptote here at x equals 0. And this graph will never cross those asymptotes. Now, later we're going to be taking a look then at what happens with other types of rational functions and how do those behave in terms of their asymptotes from there. But this is the reciprocal function, some key features, and you can kind of work on some things now from there.